In this video, we are going to be looking at arithmetic sequences represented in recursive form. Remember, there are several ways that we can represent arithmetic sequences. One is to write out the numbers of the sequence, like this. We can also write a formula in explicit form, and we can use recursive form, which is what we will be talking about in this video. I have an arithmetic sequence written out right here, and the first thing that I want to do in order to build a recursive equation or recursive formula out of this sequence is to identify the starting value and the common difference of this sequence of numbers. And so the starting value is what I have written here in yellow, and so that is -2. So I'm just going to write out that my starting value is -2. You might also hear the term initial value. The next thing that I want to identify with this sequence is, what is my common difference? In other words, what is the number that my sequence is going up by at each step? So to go from -2 to 3, I would need to add 5. And to go from 3 to 8, I would need to add 5. To go from 8 to 13, I would need to add 5, and so on. This also helps me identify this as an arithmetic sequence. Remember, with an arithmetic sequence, we are adding the same amount at each step in the sequence, and that amount is +5. So let me write that out here. I have a common difference. Of 5. Okay, the next thing that I want to do is I want to label the numbers in this sequence. Remember that the first number in a sequence, that number is, at least for our purposes here, we're calling it A1. And the second number in a sequence, or in our sequence, is A2. And then A3, A4, A5, and so on. If we were to write A6, A6 would go right there, and so on. We have our starting value of -2, and we have a common difference of 5. And when we write that out in recursive form, we want to explain where we're starting from and what we're changing at each step. And so we write that out as a piecewise function. So it's a function that's broken up into two pieces. And here we have our A1 value. Remember, our A1 value is -2. And then below that, we'll write out our A sub n. And our A sub n is equal to whatever our previous term was, which is A sub n subtract 1, and then +5. So this might be new terminology for you. So let me explain this one more time. You have A sub 1, which is our starting point, and then for any other number in the sequence, A sub 6, A sub 7, whatever, what you're going to do is you're going to take the previous number in the sequence, which is identified by A sub n subtract 1, and add 5 to it. So let me show you an example of what this would look like. So let's say you wanted to know what A sub 6 was, for example. Say we wanted to, instead of the ellipses there, we actually wanted to write out the number. So A sub 6 is going to be equal to A sub 6 subtract 1 plus 5. And here we actually carry out the subtraction here. So we have A sub 6 subtract 1 is 5. So we have A sub 5 plus 5. And then we actually know what A sub 5 is already. We have A sub 5 identified right here. It's 18. And so we can replace A sub 5 with the number 18. So we have 18 plus 5. And then we can just continue to simplify that. 18 plus 5 is equal to 23. And so that tells me that instead of this ellipsis right here, I can actually write out what the next step in our sequence is. It's 23. And that makes sense, right? We are adding 5 at each step here, and so we would add 5 to 18 to get to the next step in our sequence, which is 23. So just to reiterate, when we want to know what A sub 6 is, for example, we just replace n with 6, and then we carry out the subtraction, which gives us A sub 5, And we know what a sub 5 is already, and which is 18, and so then we simplify from there. So a sub 6, I'll do that in purple, a sub 6 is equal to 23. So let's write out the general formula for this. We'll do that right here. So I have my single curly brace here, and then my starting value, we're calling a sub 1, and that's just equal to whatever your starting value is, which obviously is a sub 1. And so just to reiterate there, that's a sub 1 is my starting value. And then my a sub n, that is equal to my previous value, the previous value in the sequence, so a sub n subtract 1, and then plus whatever our common difference is. So let's see, I'll put that in white, plus whatever our common difference is, which we're using the variable name d. So this is our d here. And so again, this is the general formula for an arithmetic sequence in recursive form. So let me put a nice red box around it. And the easiest thing to get tripped up on here is what a sub 1 and what a sub n subtract 1 are. So just to be explicit here, remember that a sub 1 is just our starting value. That's all it is. Just our starting or initial value. And then a sub n subtract 1, which is what we have right here, this is just our previous term. It's just the previous, or I'll say the previous value. And so that's just whatever came right before a sub n. And so in this example here, we wanted to know what a sub 6 was, so we had to look at a sub 5 first. And if, let's say we wanted to know what a sub 20 was, well, with this setup, we would have to know what a sub 19 is and a sub 18 and so on and so forth in order to work our way backwards to this starting value. And so let's work a few examples of this. So let's say that I have the sequence, let's see, 33, 34, 35, 36, and so on. Maybe you've seen this sequence before. The first thing we always want to do here is we want to identify our starting value, which is 33, and then we want to identify our common difference, which is 1. We're just adding 1 at each step here. We just have the natural numbers here. We're just counting up from 33. And so to write this in recursive form, or to write a formula for this in recursive form, we have our a sub 1 value. We need to know our a sub 1 value, and then we also need to know what a sub n is, or what a general term in the sequence is. And so a sub 1 is 33. Let me write that 3 a little better, 33. And then a sub n is equal to our previous term, or the previous term, the term immediately before n. So it's a sub n subtract 1. And then our common difference is 1, so it's just plus 1. And this piecewise function here, these two equations, these describe this entire sequence. Remember, you're just starting at 33, you're counting up by 1 each time. Okay, let's do another couple of these. So let's say that I have the sequence, let's see, 12, 5, -2, and -9, and so on. So if I want to write out a recursive form for this sequence here, the first thing I want to do is I want to identify my starting value, which is 12. And the next thing I want to do is I want to identify my common difference. In other words, what do I need to add or subtract to get the next number in the sequence? And so to go from 12 to 5, I need to subtract 7. And then again, subtract 7 to go from 5 to -2, subtract 7 to go from -2 to -9, and so on. And so I can combine those two pieces of information together into my piecewise recursive function here. So a sub 1, or my starting value, is equal to 12. And then a sub n, or any particular term, is just going to be equal to whatever my previous term is. So a sub n subtract 1, a sub n subtract 1, and then plus my common difference. So my common difference is -7, so we could say plus -7, or just subtract 7 here. And so this function right here, this describes in recursive form this entire sequence. We're starting at 12, we're subtracting 7 at each step. All right, let's do one more here. Let's say that you are given the recursive form of a sequence, and that recursive form is, let's see, how about a sub 1 is equal to 9, and a sub n is equal to a sub n subtract 1 plus 6. So we want to write out the actual terms of this sequence based on this recursive form. And so I know that my starting value is 9, so I'm going to write out 9 here. And then I'm adding 6 at each step. And so 9 plus 6 is 15. And then 15 plus 6 is 21. Let's write out a couple more. 21 plus 6 is equal to 27. 27 plus 6 is equal to 33, and so on. And so just to color code this like we've done with the other numbers here, or the other sequences, my starting value is 9. That's my a sub 1, or my starting value. And then my common difference between each of these terms is positive 6. I'm adding 6 to go from each term to the next term. So these are several examples of arithmetic sequences in recursive form. Remember, we want two pieces of information. We want the starting value, we want the common difference, and we use those two pieces of information to construct the recursive form. A sub 1 is our starting value, and then a sub n is just equal to whatever the previous value was, the previous term in the sequence, plus whatever the common difference is.